Hi ladies, in this video I'm going to go through the solutions for your indices and surds revision. Now, there are questions on here that you won't be assessed on, but that doesn't mean that you shouldn't be practicing them, because you will see surds and indices again next year and in BCE, and if you go on to do any thing related to maths in university or in your workplace, surds and indices are, just as common as fractions and decimals and stuff like that. So it's just another way of representing a number. Okay, so we're going to start off. There's quite a few surds questions I've noticed with these multiple choice questions. As I've said many times before, simplifying surds is probably the hard part or hard topic within surds at year 9. The adding and subtracting, multiplying and dividing are a little bit more straightforward. It's the simplifying. So if you can simplify surds, you should be okay with adding and subtracting and multiplying and dividing. Okay, so let's start with the first question, and I can just see square root of 72. It's always a good idea to write, I'm just going to write solutions here, your square factors. So 4, 9, 16, 25, 36, and I usually just keep going until I've run out of room on my page. Obviously they do keep going, but it's highly unlikely you're going to need the larger one. So the square root of 72, what we need to do is find the highest square number that goes into 72. So that's going to be 36. When you're simplifying, just rewrite 72 with your square factor first, so 36. So 36 times 2 gives you 72. The reason why we write the 36 first is so I remember that I do square root of 36 times the square root of 2. Square root of 36 is 6, so 6 root 2. So the correct answer for that one is D. All right, question 2. Now, when you're doing the square root, we do this of a fraction, it's this, what we've got here, is the same as the square root of 8 over the square root of 25. So what we need to do is simplify both of them. So the square root of 8, thinking of your square factors that I wrote on top of the sheet, the highest one is 4, so 4 times 2. And then the square root of 25 is 5, so I can just write 5 there. Square root of 4 is 2, and then we've got root 2 over 5. So the correct answer for that one is C. All right, question 3. This time we've got a multiplication. When you're multiplying, multiply any number out the front of your surd, and then you multiply the numbers inside the surd. So we're going to have 2 times 3 outside our square root sign, and then inside our square root sign we're going to have 3 times 7. So 2 times 3 is 6. 3 times 7 is 21. Before we go ahead and circle our answer, just make sure that we can't simplify the 21. So no square number goes into 21. So I've got to leave it as 6 root 21. All right, question 4. I've got a division. Now, I always prefer to write divisions as a fraction. And the reason for that is I read things vertically. Okay, so I can see that 8 over 16 simplifies, and I'll just set up my fraction to 1/2. And let's just do each part separately for now. So I've got a half, and then I can separate these numbers from the surd because I need to do this division here. So I've got also, and there's kind of like an imaginary multiply sign in there. 18 over 6. So 18 divided by 6 is 3. So it's a half times root 3. And just put everything back together, root 3 over 2. So this one's a little bit harder, that I need to separate the, well, I don't need to, but to make it easier to solve, I've just separated the, I guess, the whole number part or the integer part from the surd part. So I've kind of treated them as two separate fractions just to make it easier to solve. So we've got root 3 on 2, which is E. All right, moving on to question 5. So here we have negative indices, and we've got to represent it as with positive indices. So always set up, we've got a division here. So I just always set it up and just treat everything individually. So I've got a 6 and a 9. So I can simplify that because the highest common factor that goes into 6 and 9 is 3. So that's going to become 2/3. Now, you can do your subtraction now, which I might do. So we've got x. Remember, when you're dividing your, when you're dividing bases, your powers are subtracted. So that's index law number 2. So we're going to have x to the power of -2 minus -5. And I'm going to have to just make it a bit bigger for my y. And then we've got y to the -1 minus 3. So I've got 2. Now, -2 plus 5 gives me 3. Then we've got y, -1 minus 3 is -4 over 3. Now, remember, we've got to put it in positive indices. So anything that has a negative power just goes on the, well, if it's on the top, it goes on the bottom, and if it was on the bottom, it goes on the top. So we're kind of just moving it. So 2x cubed over 3y to the power of 4. Which is B. All right, question 6, the square root of 10x to the power of 8. So remember, the square root is the same as the power of a half. So we're going to have 10 to the power of a half and y to the power of 8 all to the power of a half. Okay, so we're taking the square root of the 10 and the x. Oh, sorry, I've written the wrong for a numeral. Let me just get rid of that y. It should be an x. Okay, so both the 10 and the x are taken to the power of a half. So just leave 10 to the power of a half. Then 8 times a half is 4. So x to the power of 4. So it's going to be A. All right, question 7. So we've got 5 to the power of 3 on 2. So the 3 on 2 we can actually separate to be a half to the power of 3. So I've just taken the 3 on 2 and separated it. When you think about it, 3 on 2 is the same as 3 times a half. So I've just separated that multiplication. So I've got 5 to the power of a half, which is the square root of 5, all cubed. Now I can just see here that that is none of those options. So you need to know that you've put the half inside the bracket and the 3 on the outside. You can also do, and I might just write or here, 5 to the power of 3 to the power of a half. Now 5 to the power of 3 is 125. And the half means we take the square root, so it's the same as C. Okay, so when you've got a power where the fraction, the numerator in the fraction is not 1, so it's not a unit fraction, you just separate. Okay, so here we've separated it with the half inside the bracket and the 3 outside. So that's the same as the square root of 5 cubed. And I've noticed it's not one of my options, even though it's not wrong. So then I've just written the 3 and the half the other way around. So 5 cubed gives me 125. So 5 times 5 times 5. And a half is the same as the square root. So your answer for that one is C. Okay, question 8, the square root of 108 in its most simplified form is. So again, we need to find the highest square number that goes into 108. So I got to really think about this. I think it's 36. I kind of do cheat and look at my answers. So if it's a multiple choice question, you can have a look at the number at the front of the surd, or the integer. And when I saw this 6 here, I thought, well, does 36 go into 108? And it does. So 36 goes into 108 3 times. So then we just separate the 36 and the 3. So we have 6 root 3. So the answer for that one is E. All right, question 9. We're going to just separate our... Sorry, I'm just thinking before I do that. Sometimes you need to see if you can simplify that 27 over 49. So if there is a high, and I know 9 goes into both of them, so I could have done that, but I might just do it this way. Okay, the square root of 27, the highest square number that goes into 27 is 9. So we're going to have 9 times 3. And then on the bottom, square root of 49 is 7. Square root of 9 is 3. So we've got 3 root 3 on the numerator and 7 on the bottom. 3 root 3 over 7. There we go. Question A, option A. Okay, question 10, we've got multiplication here. So we multiply the integers first. So 2 times 4, and then in the surd, 3 times 5. So 2 times 4 is 8. 3 times 5 is 15. And I can't simplify the 15, so it just stays 8 root 15. It's a nice, easy one. Okay, question 11. So similar to before, let's do the 6 root 14 over 18 root 7. So I'm going to separate the 16 and the 18, or the integers, from the surds. So 6 over 18 becomes 1/3. And the square root of 14 and 7 I can rewrite as 14 over 7. I feel like I didn't make sense then. Okay, so 14 over 7 is 2. So 1/3 times root 2. Don't forget there's a little imaginary multiplication sign in there. So root 2 over 3. Root 2 over 3. So your answer is D. All right. Question 12. So I'm going to set up my fraction again. So let's look at the integers, or the coefficients. So 6 over 4 becomes 3 over 2. All right, let's just do our x's first. So remember, when you're dividing, you subtract your powers. So -3 minus 2. Then y to the power of -1 minus -4. So the 3 and the 2 stay. X to the -5. Then y to the -1 plus 4 is 3. So we're going to have 3y cubed on top. And the x, because it's a negative power, goes down the bottom. So 2x to the power of 5. So where are we with that one? C. Okay, let's scroll down. If x is positive 16, the square root of 16, x to the power of 10. So let's just take the square root of 16 and then the square root of x to the power of 10. So the square root of 16 is 4. You can rewrite the x to the power of 10, so the square root of x to the power of 10 as x to the power of 10 to the half. So then we've got 4x to the power of 5. All right, question 14. So similar to before. I don't think it's the same question though. I think the fraction is definitely around the other way. So remember, we just need to separate the 2/3. So you can do 1/3 squared. So that would be the cubed root of 5 all squared, but you can see that's, oh, that is not, no, it's not one of the answers, sorry. And so, or you do it the other way. So 5 squared cubed root. So 5 squared being 25, and we can write the power of a third as the cubed root. So cube root of 25. Here's our answer, B. Okay, I just need a sip of water. It's taking forever. Lots of questions. Okay, so this one here, again, just working your way. I might need a bigger line. All right, 8/10 becomes 4/5. Just do your x's first. So x to the power of 3 minus -4, y to the power of -7 minus -3. Am I going to fit the w in? W to the power of 3 minus -2. So I might just double check that I've done that all correctly. So they're all, okay, good. So 4/5. 3 plus 4 is 7, so x to the power of 7. -7 plus 3 is -4. And then w to the power of 3 plus 2 is 5. So we're going to have 4x7 on top with the w. And that y comes down the bottom. So 5y to the power of 4. And it's going to find the answer, and it's B. Okay, question 16. We've got the cubed root of 21 x to the power of 18. So separating each of them. So I can see my answer, it's written it in index form. So I'm going to do 21 to the power of a third instead of writing it as a cubed root. And then x to the power of 18 to the power of a third. So 21 to the power of a third. 18 times 1/3 is 6. So 21 to the power of 1/3, x to the power of 6. All right, question 17, the square root of 48. So we need to look for the highest square number. So that is 16 times 3. Just want to double check that. 16, yeah, cool. And then square root of 16 times the square root of 3. Square root of 16 is 4, so we've got 4√3. All right, question 18, a multiplication. You can simplify the root 12 and the root 8 straight away if you want to, but I prefer to do it at the end. It depends whether you can do 12 times 8. So if you ever have trouble with your multiplications, just do 10 times 8, which is 80, and then 2 times 8 is 16. So 18 plus 16 gives you 96. All right, so then we need to find a square factor that goes into 96. So I think it might be, 16. Again, you can look at your answers, 16 times 6. So 16 times, yes, I think it's 16 times 6. So I was looking at the options to help me. So this one with the 4 out the front, I knew it had to be 16 and then the 6. So 16 times 6. So 6 times 10, 60. Cool. It is 16 times 6. And then the square root of 16. Square root of 6. So the square root of 16 is 4. Now, if you needed to, you could simplify the square root of 12 and then the square root of 8. So I might do that over here just to show you. So square root of 12, 4 times 3. Square root of 8 is 4 times 2. So we're going to have 2 root 3 times 2 root 2. And then 2 times 2 is 4. 3 times 2 is 6. Okay, so you could do it that way as well, which seems a little bit easier. Maybe I should have done it that way at the beginning. All right, let's get stuck into, did I circle my answer? Yeah, let's get stuck into the short answer questions. All right, so remember when you're adding or subtracting surds, they need to be like surds. So when you're multiplying and dividing, they don't need to be like surds, but when you're adding and subtracting, they do need to be like surds. Now, because I don't have much room on the sheet, I'm going to probably skip a step. So square root of 8 is 4 times 2. Now, there's always a trick in like when you're assessed on these, because they're usually written so you have the same, so that they're like surds. So I can see these are all going to become root 2. So we're going to have square root of 4 is 2. So 2 times 4 is 8. So 8 root 2. Square root of 9 is 3. So 3 times 5 is 15. And then square root of 25, sorry, I've got the root 2. Square root of 25 is 5. So 5 times 2 is 10. And so 8 plus 15 minus 10, what was that? 13. 13 root 2. Just write that a little bit better. Okay, so not much room to write your answers, which is a bit annoying. Okay, so here we've got this square root of 10 times the square root of 50. Remember, you just multiply those numbers. So you can simplify here, but I'm going to do the multiplication. I forgot to write my 7. So 10 times 50 is 500. So we've got negative 7. And the highest square factor that goes into 500 is 100. So 100 times 5. Oh. And square root of 100 is 10. So we're going to have negative 70 root 5. Okay, question C. So when we're squaring, we square both the integer and the surd. So 2 to the power of 2 and the square root of 3 to the power of 2. 2 squared is 4. Now the square root and the square cancel each other out. So it's going to be 4 times 3, which gives you 12. When you do one like brackets, you're just multiplying like that. So it's going to be 2 root 2 times root 6 minus 2 root 2 times 3 root 5. So we've got 2 root 12 minus 6 root 10. And I just need to simplify the root 12. So that's going to become 2, 4 times 3 minus, and the 10 can't simplify. So we're going to have 4 root 3 minus 6 root 10. And I might just double check that because I feel like I've made a mistake. So 2 and 6, cool. 2, 3, 2, 5. Okay, it looks good. I was just wondering if it did come out that I could do that subtraction, but maybe not. Okay, so question E. Everything inside the bracket is taken to that square, but we leave the negative there. So 2, we have 2 squared. And root 5, so the square gets rid of that square root sign. So the square root and the 2 cancel each other out. So now we've got negative 4 times 5 gives you negative 20. Okay, I don't know why we had so much space for such an easy question. I feel like maybe I should have a bit more. Okay, Multiply your integers. So 5 times 2 is 10. Now, you can go and do 12 times 27, but it's probably easier to simplify. So the square root of 12 becomes 4 times 3, and the square root of 27 is 9 times 3. So we're going to have 10 times 2 root 3 times 3 root 3. And then we've got 10 times 2 is 20, times 3 is 60. Root 3 times root 3 is root 9. So we've got now 60 times 3, which is 180. All right, so for question G, we've got 2 root 98 over 3 minus 4 root 32 over 5. So let's just simplify the 98 and the 32. So square root of 98 is 49 times 2 over 3 minus 4. 32 becomes 16 times 2 over 5. Okay, square root of 49 is 7. So 7 times 2 is 14. So 14 root 2 over 3. Root 16 is 4, so 4 times 4 is 16. We've got 16 root 2 over 5. Now, you're going to have to put them as over the same denominator to do your subtraction. So when we do that, we multiply that by 5 and that by 5, and this by 3 and this by 3. So 5 times 14, so 50, 70 root 2 over 15 minus 3 times 16 is 48 root 2 over 15. Now we've got 70 root 2 minus 48 root 2 over 15. 70 minus 48 is 22. So 22 root 2 over 15. And I can't simplify that any further. I'm just checking. So yeah, this question here, it seems like a complicated one, and it's quite a lengthy question, but the same rules apply. So as long as you understand your index laws and your surd laws, you should be able to do questions like this. And always check using your calculator. So I might just check now using my calculator to make sure it's correct. All right, all good. Let's move on to question H. So got 2 root 2 times this. Okay, so we've got to do this multiplication first. So I'm going to do it in one go. So 2 doesn't multiply with anything. So 2 times 6 is going to be 12. 2 times 4 is 8. And then 2 times 3 is 6. And then we've got minus root 3 on the end. So I'm just going to make sure I've done that correctly again, because sometimes I miss things and then I have to go back and check the videos, and that just so time consuming. Okay, let's simplify 2 root 12. So the 12 can be written as 4 times 3 minus 8 root 6 minus root 3. So then we've got 4 root 3 minus 6 can't be the root 6 can't be simplified. But we've got like terms here. We've got the 4 root 3 and the minus root 3. So we've got 3 root 3 altogether. And then minus 8 root 6. Remember, they're not like surds, so we can't do that subtraction any further. All right, question 2, write these numbers as a basic numeral. So basically, write your number first. So it's 4065 without the decimal place. And we're moving it from here, and I'm just doing that in a different color so we can see it. We've got to move it 6 places. So if you're ever unsure which direction to move it, a positive power means you're making the number bigger. So to make it bigger, I need to move it to the right. If it's a negative power, I move it to the left because that makes it smaller. Okay, so we've got 1, 2, 3, and then just add your zeros in. 4, 5, 6. So we're left with 4, 0, 6, 5, 0, 0, 0. And I always just double check that I've moved it enough spots. So I've got 1, 2, 3, 4, 5. What? Did I add too many? Hold on. 1, 2, 3, 4, 5, 6. There we go. All right. 9.7 times 10 to the negative 3. So write your 9 and your 7. Now, I'm just doing it a different color again. So my decimal place was here. The negative means I moved to the left. So we've got 1, 2, oops, what am I doing? 3. Okay, so always rewrite it 0.0097 and double check. So we've got 1, 2, 3, all good. All right, question 38203. Just do the decimal place in green. So we're going 5 spots. 1, 2, 3, 4, 5. So now we've got 820300. Just double check. 1, 2, 3, 4, 5. Good. Okay, then question 416. Our decimal place was here. So it's getting smaller. It's a negative power. So 1, 2, 3, 4. So it's gone here. All right, so we've got 0. Not very nice. 0, no. Oh my gosh. Video is too long and now I can't talk clearly. 1, 2, 3, 4. Good. All right, question B, write the numbers using scientific notation. So when you're writing scientific notation, you always start with the first non-zero number. So here it's 8, and then we just put our decimal point. So we only have a single digit and then our decimal, and then any numbers after that until we get to the last non-zero. All right, and then count up how many decimal places your decimal point has moved. So it's gone 1, 2, 3, 4, 5. So it's going to be times 10, and the number is a big number, so it's going to be a positive power. Question 2, we've got 00016, so we just ignore those zeros until we get to the first non-zero, so it's going to be 1.6, and then just move your decimal point. So 1, 2, 3, 4. So times 10, it's a really small number, so it's a negative power. Just double check that I've counted correctly. Good. All right, so question 3, we've got the 4.065, and then count how many decimal places it's moved. So 1, 2, 3, 4, 5, 6. So times 10 to the positive 6. And then the last one, we've got 9.703. And then move your decimal place. So we've got 1, 2, 3. Alrighty. Question 3, evaluate the following without a calculator. So 64 to the power of a half is the same as the square root of 64, which is 8. Oh, we've got a negative fraction. Okay, so this is the same as 1 over 27 to the power of a third. So it's 1 over the cubed root of 27. So the cubed root of 27 is 3. So it's 1/3. 81 to the power of a half is the square root of 81, which is 9. Question D is 1 over 8 to the power of a third. So that's going to be the cubed root of 8. I wouldn't usually write that because it is the same thing, and that's going to be a half. All right, evaluate each of the following without a calculator. So 4 to the power of negative 2 is the same as 1 over 4 squared, plus 5 to the negative 2 is 1 over 5 squared. So 1 over 16 plus 1 over 25. Now, to add them, you do need the same denominator. Oh my gosh, I might just quickly do that. Otherwise, you could be waiting a while. All right, so that's going to be 41 over 400. Now, a question like that, it does say without a calculator, but I'm just thinking as I go, obviously, it will take you a while to do 16 times 25, but you'll get there. All right, question B. So the 3/4 is taken to the negative power. So that just means we flip. So the 4 goes on the top now and the 3 goes on the bottom, minus 1. And when you're subtracting fractions, you need the same denominator. So 1 is the same as 3 over 3. So 4 thirds minus 3 thirds leaves you with 1/3. All right, question C. So we've got 2 to the power of 5 times 3 times negative 4 is negative 12 over 2 to the negative 3. All right, when you're multiplying the same base, you add your powers. So 5 plus negative 12 is negative 7. And then let's do the division. So when you're dividing by the same base, your powers are subtracted. So negative 7 minus negative 3. So we're left with 2 to the, what is that, negative 4? No, yeah, negative 4. So that's going to become 1 over 2 to the power of 4, which is 1 over 16. All right, question 5. The cubed outside the bracket means everything inside the bracket is cubed. So 3 cubed is 9. Then we've got x to the power of 2. 2 times 3 is 6. Y cubed all over. Now the 5 isn't inside the bracket, so we don't square it. So negative 3 squared is 9. Then x squared, y squared. And then divided by anything to the power of 0 is 1. 10y to the power of 4. Okay, let's just tidy this up a little bit. So 5 times, well, those 9s actually cancel each other out. And we're just left with 5 on the bottom. The x's, because we're dividing, we subtract our powers. So x to the power of 4. And then y to the power of 1. And when we're dividing by a fraction, we multiply by its reciprocal, so 10y to the power of 4. And then we're left with 10x to the power of 4, y to the power of 1 plus 4 is 5 over 5. And then 10 over 5 is 2, so 2x 4y to the power of 5. Okay, that looks like a 9. I might just try to change that into a 4. It's a bit better. Okay, question B. So when you have a negative power, it just changes. So I'll just draw my fraction first. So the a goes on the bottom as a to the positive 5, and then b on top as b to the positive 4. Now I'm going to just do the multiplication first. So 2 times negative 3 is negative 6, and then 2 to the negative 3, a to the negative 3, b to the power of 4 over a to the power of 5. Okay, the b can go down the bottom, b to the power of 6. The 2 come up the top as 2 cubed, and the A comes up the top as A cubed. Okay, so I'm going to put everything on the numerator. So we're going to have 2 cubed is 8, A cubed, B 4, and then on the bottom we've got A 5, B 6. So the 8 stays on the top, and then on the bottom we're going to have A to the power of 2, B to the power of 2. All right, and that's it. Wow. Very long. But girls, very complicated questions there, but they will test your understanding of the index laws. Okay, bye.